it's going to require for you to be able to operate those types of environments. You're going to rely more and more on those operational considerations being built directly into the code. From an architecture perspective, it really is maybe oversimplified, but this is basically what we're seeing. It's really about the distribution and the scale out. And that's where the microservices is coming from. Microservices themselves cause some operational headaches, I guess is the best way to put it. Now you've got a bunch of these little microservices running out there. And part of the challenge is, and I think again this is where operations comes into play, working with the developers, is if left to their own devices, some developers will take this too far to the extreme, and you're going to have microservices with literally, one service running in it. So you're going to have hundreds of these microservices out there. And this is something we just experienced recently. A colleague of mine got called into a pretty large customer where they deployed this, and the performance was just horrible, and they couldn't figure out why. He went in and did some analysis, and what he found was it was all the chatter between the microservices. That's what was slowing everything down. So operations became a victim, if you will, of the developers and these new ways of factoring these applications. So I think there is a happy median to be reached as far as these microservices are concerned. How many services go into defining a microservice, and it can't be one service per microservice. Yes.
I was kind of thinking in the past in the traditional applications, IT has built, the availability, recoverability solutions. Suddenly you're expecting the application.
Yes.
Isn't there a risk here that, are they actually writing it in the right way? Who's responsible?
Absolutely, there's a huge risk here, and that's why I say, and probably the main theme of my presentation here is the absolute importance of operations working with development as early in the process as possible. So I'm not going to do a spoiler here. I'm just not going to do it. I'm going to wait till a bit further. But that's the whole point here, is that you're absolutely right. Whether it be from a provisioning and deployment perspective, whether it be from a DR perspective, a high availability perspective, all that is being increasingly pushed up into the application. And that's why I say before, operations is losing a level of control here.
But you might be blamed at the end of the day.
Absolutely. Yeah. Absolutely, at least for quite a while.
Normal,
yeah, that's normal. Absolutely, you can bet operations is going to be blamed no matter what. I mean, that's what happened in the case of this. The little anecdote I was just saying about the microservice. Operations was being held accountable for the performance. Well, it was actually the way the application developers developed the microservices and created all this chatter between the microservices, because they had so many microservices. They had taken it, down to a level of granularity that was, just beyond what was really needed, and it was causing problems. And you're just going to increasingly see that. So, in order to nip that in the bud, it's all about working with developers and getting much more involved with developers from an operational perspective. I can't think of any other way to do this. Otherwise, it's gonna be back to where it has been, and probably even worse, where operations is not going to be blamed, but operations is going to be the one that's up all night trying to figure this out in a high pressure incident situation. So we talked a little bit about the Linux containers as the lightweight containers in which these microservices and newly factored applications run, and increasingly, I can't get away from this as much as I'd love to, because of the operational implications, all the open source components that are in there. The ideal situation there is, and we've worked with some companies to do this, it's not easy to do, because all of that, there's a lot more being pushed down, decision-making being pushed down to the line of business, and developers are really becoming the control points for a lot of this. But arriving at some kind of level of standardization on the open source components that are going to be used. I've seen, unfortunately, I've been in customers where they've left the developers make all the decisions and use whatever they want to use, and you've got 15 development teams all using different components, different development tools, et cetera, et cetera. So there's got to be some kind of standardization put around that as to the types of open source components that can be used. I believe there needs to be some kind of, and we've done this and it's worked well, some kind of design authority put in place that includes operations, architecture, development to arrive at some kind of agreement on what are the components that are needed and used. And if a development team really feels strongly that they need some other component that hasn't been agreed to, that needs to be brought to the design authority, and an agreement has to be, they have to have the authority to make those decisions on the types of tools and open source components that are used in these applications. Otherwise, it's going to be complete anarchy. I'm already seeing it being complete anarchy, unfortunately. And once you go down that path, trying to pull back is nearly impossible. Then it falls back on operations' shoulders once again to have to deal with all these different components. How do you monitor for these components? How do you understand what these components do and what the implications of these components are? So from a change in the application architecture for the cloud, we're moving away from those more monolithic layered applications, your multi-tier applications, to these microservices-based applications. And from an operational perspective, that, I'm going to be completely honest with you, that is scary to me. And I'm not the person having to operate these environments, but seeing what kind of damage these can do from an operational perspective if there isn't some kind of, I don't want to say control, but some kind of collaboration between operations and development. These microservices, if we thought we had virtual sprawl, VM sprawl, just wait and see what it's going to look like a year and a half from now from a microservices perspective. It's going to be like having little nanobots running all over the place in your environments. So again, really working with developers, helping them understand what the implications are and what can they do in their code in order to take into account some of these operational considerations. So it is a small code base per service, but again, I think that that's a pretty subjective statement. And unfortunately, this is also new that there really aren't any, that I found at least, any real good detailed standards for this. They're still all under development or just now being thought of because this is all happening so fast. So once again, to me, that puts, I don't want to say puts the onus on operations, but I think from my perspective, what it does is, operations needs to be a bit more assertive, or very assertive about having a voice in all of this. Not, to dictate, but to collaborate with developers. I'm sorry, yes?
Are you seeing dependencies between the backend system, say a database, and microservices that kind of collecting data out of some of the backend system? Or are you seeing those types of integrations?
I haven't seen that yet, but you know how creative developers are. If it's possible, it's going to be there. It's just not something that I've run into yet. But again, this concept of microservices has opened up a whole can of worms from an operational perspective, in my opinion. It had to do with different packet systems for these. I think what you meant was you have different microservices that are using different packet systems to interact with the database.
Yeah.
So again, to me, it comes back to having some kind of standards in place that operations has a say in. Again, a design authority that can be put in place to put some structure and some kind of flexible, but still some kind of standards in place from a development perspective. So at least if they're using a packet service, there's just one that they're using, if at all possible, or something, or two at most. And then with that, being able to build the monitoring capability specific to those types of packet microservices because you were involved early enough to understand what they do, what they are. All the other stuff we've been hearing about, the easy, independently maintained, frequent updates, distributed and easily scalable. This is absolutely the required architecture for applications at cloud scale. But going back to all the things I said, this has, to me, very scary implications for operations, and I believe operations needs to assert itself to get involved with the developers as early as possible in the process to set some standards around this and help them understand what the operational implications are and what can they put into their code base to allow you to be able to operate those environments. 12-factor apps. Again, I apologize, I probably could have put a couple more slides in about this one. But this is a pretty large subject in and of itself. How many have heard of this? It's called 12-factor, there's a website, 12factorapps.net. How many have heard of it? I'm sorry, I didn't see hands. Okay, good. I thought this was, we have found this to be a very valuable resource. It really lays out, it was built or it was designed originally for SaaS applications. But it applies pretty nicely to these new cloud-native applications. So there's things in there like I spoke before about using the logging using an event stream and logging. That was an example out of this 12-factor apps. So really, what this is meant to be is to put some guidelines in place to help understand what are the, primarily from an application perspective, what's needed to create what we're calling these cloud-native applications. But I saw this as being, this has been a good source for us to look at what are the operational implications. And what I said before, there's just a whole lot more tools and a whole lot more open source, et cetera, et cetera. So there needs to be some kind of control put around this with appropriate level of flexibility. Again, what we have found to work very well is this idea of a design authority. I mean, we've used that for a long time, just generally for doing software-defined data center type deployments where it's a larger transformation. There's people in process involved as well, and where we've included development in this to address these types of issues, it's worked very well. So, and for those of you who were, as I mentioned to the two gentlemen before, were in our discussion yesterday about DevOps, this is going to look very familiar, so I'll just tell you right now if you want to go get some coffee. There are a few twists to it, but it will look very familiar if you were in Ahmed and Mai's session yesterday afternoon. But I hope what I've been saying to this point leads up to this conclusion that the ops and DevOps is even more critical when we're talking about these new types of applications, these cloud-native applications. In fact, a couple of you might be able to come up and just give this part for me, and I can get coffee. So the challenge, as I said before, the developers are being pressured to do more and more releases in order to support changing business needs. To date, it's been pretty much a manual process for how they move through their software development lifecycle. Operations has had to deploy new environments for them every single time they move from stage to stage. Dev wants to push more quickly into production, but operation wants stability, not just wants stability, it has to have stability in order to keep the business running. And there is where, from my perspective, the DevOps conflict comes into play. It's that, I like to think of it as creative tension between development and operations. I think if operations gets involved with development early, it can become creative tension instead of just flat out tension. And as a result, no operational surprises. That's what operations needs. And the only way to do that is to get involved with development early and often.
Sorry, use AT, I think that's certain slides before.
User acceptance testing? Yeah, and this is just an example. I mean, there's as many stages defined in the software development lifecycle as there are development teams, it seems like, within a company, which is something else that would be nice to standardize. Yeah, so that's user acceptance testing. Another one in here that I should have included that comes in very handy is operational readiness testing. How many of you are fortunate enough to do any kind of operational readiness testing before you deploy something? Anybody? 1, 2, 3, kind of? Yeah, that's...
You end up doing it anyway.
I'm sorry?
You end up doing it anyway.
Yeah, you do, but it would be nice to kind of formalize that before you have to actually push something into production.
Yeah.
And for those of you who don't have that in place, I would encourage you to look at that. That's something that has saved our proverbial bacon many times, is one of our standard procedures, if you will, when we go in and work with customers in standing up environments that involve moving applications into production, is to put in place an operational readiness testing stage as part of that software development lifecycle. And again, like I said early on, this is still an area we're developing, where developing automated test capabilities in that operational readiness testing stage. And really what that's meant to do is give operations a one final view at what is being pushed into production, so that they are, in the end, operationally ready for that. Yes?
Just thinking through this, I mean, we've got development, we've got ops and stuff. Where would you place infrastructure? Would you try to bring somebody that manages or owns the infrastructure into this whole thing so they also know what is being required of them?
Well, that's a good question. So the question is, the gentleman didn't see infrastructure mentioned in here, and where does infrastructure come into play? I think I've got one of the next slides. I'll address that, and if not, I'll address it anyway. So give me 1 second here. So why ops? There's two main areas where ops needs to come into play when you talk about DevOps. And what I've seen, only one of those two are really where the focus seems to be today, and that is the first one on deployment. The second one is the area that I'm not seeing much attention paid to, and I think that it's equally to, if maybe not more important, than the deployment aspect of operations working with development. So I'm going to talk about each of these a little bit more. And I do believe my slide is in here well, I'll address your question. So there is you've got these stages in software development lifecycle. The idea is for operations to work with development. Well, I guess I asked the question first. How many of you are already working with development kind of at this stage where you're intimately involved with automating the deployment of these environments between the various stages? Okay. So some of this won't be a surprise to any of you. But the idea here is, and what virtualization does, is it allows you to more easily create absolute duplicate, or not duplicates, just the same environment between the various stages. The idea is not to recreate it every time, but make use of blueprinting capability like in vRealize Automation, to where it's moving from, moving the application between stages to redeploying the entire environment in which that application runs in each of the stages. So, and then with tools like CodeStream, what it does, for those of you who aren't familiar, what it does is it automates the promotion of the application, the environments, from stage to stage to stage. And what it does is it provides, and that's what I added to this, these little gating rules. One of the ways that it automates and controls is it implements these gating rules that can be defined that say, if you meet these criteria, you can automatically be promoted to the next stage. And that works throughout. So where a lot of the focus is today from a DevOps perspective is operations supporting development for this. to help them to understand what their application needs are, develop those virtual environments for them. How many of you have worked with blueprints in the context of vRealize automation? Okay. That's what we're finding, that's a great tool for doing this. What a blueprint does is it allows you to encapsulate the deployment and configuration of the environment and the application from a blueprint. So that blueprint will go out and make the calls via vRealize Orchestrator. It'll make the calls out to Puppet or Chef or whatever it might be to do your automated configuration. So another step in here then, what we're doing internally at VMware, and we're starting to do with customers, is a lot of the emphasis is being put on those blueprints. So sometime, let's say something's moving through the stage, it goes to CI, and it runs through the automated tests, something fails, so it automatically gets sent back. In addition to, from an application perspective, understanding why it failed and making the corrections, equally as important, it's about going into the blueprints themselves and making the associated corrections so that you, again, just redeploy from scratch every single time based on that blueprint. So you're guaranteed between these stages, or when you move to a stage, if it does a redeploy from the blueprint, when you're in CI, it's going to be, you're guaranteed that it's going to be exactly the same as it was in development. So by the time it gets out to production, that whole environment has basically been tested through each of those stages. So that lowers the risk when it gets to production. The other thing it does for you is ideally, developers are working in the same environment that's in production. So you're kind of guaranteeing that based on these blueprints. But you want to have them be basically working in the exact same environment that they would be working in production itself. Okay, this was the slide I was looking for. Yes?
Just real quick on the development environment. I know in my company and other companies that it's beginning to be non-practice where developers actually have a full environment. And the cost of that is, depending on the number of developers you have, the cost goes way up. So in the development cycle, you really, you're bound by your unit test and your component test. You have to have full coverage, and you never go into a full environment in your development environment. And not until you get pushed out to a shared environment that then you're running with live services.
I would agree. And the key there is the live services part. What we've been working with customers to do is at least stub those out so that you can simulate those live services.
Every microservice should deliver on.
Yes.
Like if you go to component test, you're relying on this.
Yes. Yes. And also why that operational readiness testing environment becomes important, because what we've tried to do there too is be able to, wherever we can, replace those stubs with the actual access to the live services in that operational readiness stage. Okay, so this was the slide I was looking for to address the question about the infrastructure. So in the process that we use, since again we're all about moving IT towards becoming a service provider, being more service oriented. What we do is we have a service definition process, a 360-degree service definition process that looks beyond what is typically addressed when you're putting requirements together in the legacy world for, let's say, a service that includes an application. This is where infrastructure would be brought in at this point, as would operations, as would development, as would finance for costing this service, for understanding what the components are there to go into this service that contains this application. This is where you look at what are the capacity implications from an infrastructure perspective, for example. So this is the first point and the critical point where all these parties are brought together. And in the context of what we're talking about here, this is the critical point where you bring in the application architects, you bring in infrastructure, you bring in operations, so that at the very earliest stage, when all this is being formulated the first time through, operations is involved from that point forward. This helps establish the relationship between operations and development for this particular service that's going to be rolled out. This is where the operations can work with the application developers to understand what their provisioning requirements are, what does the environment need to look for, what are the integration points that need to be considered. This is the point where operations can be brought in, or should be brought in, or is brought in to understand from the developers, what are the monitoring requirements, what are the characteristics of this application that you're going to deploy into production. So this is the starting point. This is the earliest stage, at least in the process that we put in place with customers when we're doing this, where we bring all those parties together. So this is where operations first gets involved with developers in this context of DevOps. The other aspect of this, by doing that and taking that blueprint approach, is when a change needs to be done, even after it's been initially put into production, and it's in between releases or something, using those blueprints, again, it's about going back and modifying the blueprint and redeploying through the process. We've taken this to, I think, a very useful extreme, but somewhat of an extreme within VMware, where we don't fix anything in production. We'll take that environment out into a different sandbox or something to troubleshoot it. And once we find a problem, we'll modify the blueprint and we'll redeploy into production instead of actually fixing it right in production itself. So that's one of the advantages that we've found with taking that blueprint approach. So again, to answer your question on that previous slide, that's where infrastructure comes in early on to work with those developers and understand the infrastructure implications.
Yeah, I just think that this whole concept, right, is a new thing to them as well. That they want to do elasticity and those things, that they have the right things in place.
Absolutely. That's all part and parcel of those operational considerations. Or another one that we run into is, what environment does this application need to be deployed to? Is it going to go out to a hybrid cloud, or is there going to be a bursting capability out to a hybrid cloud? Are there special security requirements? And I think that becomes very important too. When I talked before about the idea where the developers are going to increasingly have direct application to APIs, they're not going to know what environment something needs to be deployed to. So by having operations involved, and the way we've done that is the developers, when they do make API calls, they'll make API calls into vRealize automation, for example, and that will force the invocation of a policy that dictates where that application gets deployed to. So the developer doesn't need to worry about it. Operations controls that in the policy itself. So monitoring, came back to the same slide, because this again is the one that I think is missed. There's a lot of focus when you talk about DevOps, in my experience, on that front end, helping the developers provision, make sure you got the exact same environment, you get it into production, et cetera, et cetera. The bit that has been missed in my experience, what I'm seeing, is the monitoring and putting the operational considerations into the code itself. Again, that's done back in this service definition phase. So why do you want to do that, and where do you want to do that? I think from an operational perspective, it's important, or it's to your benefit, to monitor their application all the way through that software development lifecycle. The reason for that is you can start seeing if there is any kind of anomalies that application causes and feed that back to development. So that's one advantage. But another real big advantage is, by the time it gets into production, you're already familiar with the characteristics of that application. So there are no big surprises when it's actually deployed into production. The other side of that, another service that operations can offer out to the developers, is developing monitoring dashboards for the developers themselves. So they can monitor the characteristics of their applications to see if it's causing any kind of anomalies directly. And I do believe, while I'm not a big proponent of the idea of developers owning their application and operations from every sense of the word, I do believe that they should have a window into their application and operations. They need to have their own dashboards that are meaningful to them, so that they can monitor their application while it's running in production. That does a couple of things. It certainly helps if there's an incident or there's a problem. They don't have to be brought up to speed and start troubleshooting from the start, because they already have dashboards that they're monitoring against, which certainly is advantageous to operations. But also, to me, that's what we've seen is it's a great way for developers to get insight into how their applications behave at scale. So, to an extent, a certain degree of performance testing can be done while it's in production. And then, like I said, while it's in production, it's about having those multiple views into the microservices, the microservices that make up these new applications, and to allow both the developers to have that view, read-only, and have operations have that view into those microservices as they run in production. Another aspect of that that is useful is it also helps operations become more comfortable with that continuous delivery concept and continuous delivery process. Because you've been monitoring all the way through, it's no longer the case like it was when I ran operations, where at 11 o'clock on Friday night when we were allowed to do releases was almost the first time I saw the application. It kind of got thrown over the fence to me, and we had to deal with it. I wish we would have had that capability of being able to, or thought about having some monitoring in place all the way through the development life cycle. It would have made our lives a lot easier. Yes, sir.
So one of the things that we've tried to implement is also from a CI perspective, right, of rolling CI on the same infrastructure in a converged area, right, that I think goes to your point of how does it actually work, as we'll drive not only the CI, but then the performance test into that, and that's that view that you get, right?
Right, exactly. Yep. Okay, lastly, what are the role implications for this? I think we're running out of time here. So this is just to introduce kind of our organizational perspective when we talk about DevOps from an operations transformation perspective. Inside the blue box is the cloud operations group. We have cloud infrastructure operations, which is the more traditional infrastructure operations. They're dealing with the underlying infrastructure, the virtualization layer down. And then we have what we refer to as tenant ops. A lot of our customers don't like that name. It was a leftover from work we were doing with vCloud Director in the early days. We did a lot of work with telcos, and they were big on tenants, so that kind of followed through. So that's what that tenant operations is. They're responsible for everything customer facing. So they own the services, they develop the services working with developers. So that's why we show the interaction with application development. The individuals from within IT that would work with application development in our model are in that tenant operations layer. We have the concept of, well, I'll go into that in a couple slides down. I think an opportunity for operations, certainly at the simplest level, we're already deploying infrastructure as a service, platform as a service to application developers. But I think an opportunity for operations is to look at something like continuous delivery as a service. Set it up as an actual service that's offered out. This can help drive that idea of a design authority. If you think about things like CodeStream in the slide a couple back, where you have this environment that's being set up and you have these gating rules that dictate how you move between stages, Developers aren't going to set that up. They want to develop. So I think that's an opportunity for operations to insert itself into that process where you're adding value to development, to the developers. You're making their lives easier, and you're maintaining some level of control even as you go through that software development life cycle. So double clicking down just one level from that organizational perspective, the roles, from a cloud infrastructure operations, a lot of the roles are pretty much what we're already seeing, but I'm just going to point out two real quick since this isn't the point of this particular presentation. But within infrastructure, automation is key to success in this world. So we've defined a cloud developer role, recognizing how important automation is. So moving away from, while there's already automation going on, make no mistake about it, what we've seen at least is it's typically pretty ad hoc. The administrators writing scripts, et cetera, It's so important going forward to be successful in cloud automation is that you need to take a more structured approach to it. So hence why we have a developer. And then we have the analyst, which is basically the individuals who are very good with tools like vRealize operations from an infrastructure perspective. From a DevOps perspective and a service perspective, it's again all about the tenant operations. So we have roles like the service, well, first of all, the service owner who owns the service from end to end. But from a DevOps perspective, when we talk about that service definition, it's the service architect that would get involved with the developers at the level of that service at the service definition stage, and start working with them to understand what the application architecture is, what are the monitoring implications, what are the deployment requirements, what operational considerations can be put directly into the code by the developers. That would be the responsibility of what we define as the service architect role. These aren't necessarily individuals, but these are roles. So some of these roles can be combined. We do that all the time. And that service architect would kind of hand off to the service developer, who would take over working with the development team on an ongoing basis. The service developer is the one who would help set up the environment in code streams, set up the gating rules, do the integration of the tools for the development team. The service developer would be the one working with the service analyst, who again is responsible for working with tools like vRealize operations, but instead of where the cloud analyst applied it at the level of the infrastructure, the service analyst would be the one who applies it at the level of the service. So this would be the role that would work with the developers to actually develop the custom dashboards, the KPIs, et cetera, that both the developers can use when they're monitoring their application through the service development lifecycle, but also that operations can use. So when we talk about DevOps, those are probably the key roles: the service architect, the service developer, the service analyst, and then for the blueprints, we also have a role of a blueprint manager and policy manager, who is actually responsible for the life cycle of those blueprints. And last but not least, I wanted to show just from that concept of continuous delivery as a service, which is something we're just now starting to implement with some customers. The roles that we've identified there are pretty much extensions of what I described in tenant ops. Got of course, the owner of the continuous delivery as a service. We've got the blueprint policy and release manager for the automated release and continuous delivery through that service development lifecycle. We've got the continuous delivery engineer, who would be that equivalent to that developer I described in the previous slide, who would actually work with the developers from a laying out the progression and the rules. The test engineer to help build those automated test scripts. And then the continuous delivery developer to go in and do any kind of like orchestrator or orchestration type development that's needed to support it. So, got about 5 minutes left here. The key takeaways from that I was hoping to get across here, there are certainly some, there are business drivers that are forcing us towards these new types of applications, what we're calling cloud-native applications. They absolutely, unequivocally have operational implications that need to be addressed as early as possible in the process. It's going to be, I would say, almost impossible, maybe not impossible, but very, very challenging and difficult if this continues where things are thrown over the wall to operations at the end, and operations has to pick up and start being responsible for making sure all these microservices now are running, for example. And I believe even more so than it has been to this point, I think this concept of really proactive and deep involvement by operations in a DevOps way is even more important now with these new types of applications, these new cloud-native applications. So with that, like I said, about 5 minutes. If there's any other questions, and of course, the survey. Any questions before we close up? Okay, well, thank you very much. And I really appreciate your time, especially considering how early in the morning it was here. Now I'm going to get some coffee.
It woke me up.
Well, that's all I can ask. If it woke you up, and that's good.